According to Article 800 of the National Electrical Code, metal fences with a height of 7 FT or greater must be grounded. The grounding electrode system must have a resistance of 25 ohms or less. To ground a chain link fence effectively and cost efficiently, consider the following practices. Firstly, install a ground rod at the gate. Connect the gate to a ground rod driven at least 8 FT into the earth. This creates a convenient point to connect the rest of the fence. Secondly, bond the posts. Use conductive clamps or straps to connect the chain link fabric to the fence posts. This ensures that the fabric and posts are properly grounded. Thirdly, use a single grounding electrode. Instead of a ground ring, install a single ground rod near the gate and connect it to the bonded fabric and posts. Fourthly, test the grounding resistance. Measure the resistance between the ground rod and the known good ground point. It should be 25 ohms or less. If necessary, add additional ground rods or move the existing rod to a location with lower resistance. In some cases, it may be practical to use alternative grounding methods such as connecting to a water pipe. If a metal water pipe is present within 5 FT of the fence, it can be used as a grounding electrode. Connecting to a building is another alternative. If the fence is adjacent to a building with a properly grounded electrical system, it can be connected to the building's grounding system. Ensure that the ground rod is long enough to reach moist soil. Use copper or copper-bonded grounding clamps for all connections. Inspect the grounding system regularly for damage or corrosion. By following these practices, you can ground your chain link fence effectively and economically, meeting NEC requirements and ensuring the safety of personnel and equipment. Let's elaborate on NEC requirements for grounding chain link fences. The National Electrical Code, or NEC, provides specific guidelines for grounding metal fences, particularly those exceeding 7 feet in height. These regulations are primarily found in Article 800, which addresses communication circuits. The NEC mandates that such fences must be grounded to ensure safety and prevent electrical hazards. The primary goal is to minimize the risk of electric shock and prevent potential damage to equipment. The NEC specifies that the grounding electrode system used for grounding the fence must have a resistance of 25 ohms or less. This requirement is critical to ensure that any fault current can safely dissipate into the ground. A lower resistance value indicates a more effective grounding system. To meet this requirement, it may be necessary to install multiple ground rods or use other grounding methods to achieve the desired resistance. The NEC permits several methods for grounding, including the use of ground rods, metal underground water pipes, and other approved grounding electrodes. The choice of method depends on site-specific conditions and the availability of suitable electrodes. The NEC also emphasizes the importance of proper bonding between the fence fabric, posts, and grounding electrode. Bonding ensures that all metal parts of the fence are electrically connected and at the same potential, reducing the risk of voltage differences that could cause electric shock. Proper grounding and bonding not only enhance safety but also help protect electronic equipment located near the fence, such as cellular tower equipment, from voltage surges and electromagnetic interference. Now, let's explore best practices for grounding a 100 FT by 100 FT chain link fence. When grounding a chain link fence, particularly one surrounding a cellular tower compound, several best practices can ensure both effectiveness and cost efficiency. These practices align with NEC requirements and aim to provide a safe and reliable grounding system. Installing a ground rod at the gate is a strategic first step. The gate serves as a central point for connecting the rest of the fence. Drive a ground rod at least 8 FT into the earth near the gate. This depth ensures that the rod reaches moist soil, which is essential for effective grounding. Connect the gate to the ground rod using a suitable grounding clamp and conductor. This creates a convenient and accessible point for connecting the entire fence. Bonding the fence posts is another critical step. Use conductive clamps or straps to connect the chain link fabric to the fence posts. These clamps should be made of copper or copper-bonded material to ensure good conductivity and corrosion resistance. Attach the clamps securely to both the fence fabric and the posts, ensuring a solid electrical connection. Bonding the posts ensures that the entire fence structure is properly grounded. Using a single grounding electrode can be a cost-effective approach. Instead of installing a ground ring around the entire perimeter, consider using a single ground rod near the gate. Connect this ground rod to the bonded fence fabric and posts. This method can be simpler and less expensive than installing a full ground ring while still providing adequate grounding. Testing the grounding resistance is crucial to verify the effectiveness of the grounding system. Use a ground resistance tester to measure the resistance between the ground rod and a known good ground point. The resistance should be 25 ohms or less, as required by the NEC. If the resistance is too high, you may need to add additional ground rods or move the existing rod to a location with lower soil resistance. Regular testing ensures that the grounding system remains effective over time. Now, let's discuss the use of alternative grounding methods. In certain situations, alternative grounding methods can be practical and effective. These methods may be used in place of or in addition to traditional ground rods, depending on site-specific conditions and the availability of suitable electrodes. Connecting to a water pipe is one such alternative. If a metal water pipe is present within 5 ft of the fence, it can be used as a grounding electrode. The water pipe must be in direct contact with the earth for at least 10 ft to be considered an effective grounding electrode. Connect the fence to the water pipe using a suitable grounding clamp and conductor. This method can provide a reliable grounding path due to the extensive underground network of water pipes. Connecting to a building is another viable alternative. If the fence is adjacent to a building with a properly grounded electrical system, it can be connected to the building's grounding system. This method can be particularly useful for fences located close to a building with a robust grounding infrastructure. Connect the fence to the building's grounding system using a grounding conductor of appropriate size. Ensure that the connection is made to a designated grounding point within the building's electrical system. Let's address some additional considerations to keep in mind. When implementing a grounding system for a chain-link fence, several additional considerations can enhance its effectiveness and longevity. Ensuring that the ground rod is long enough to reach moist soil is critical for effective grounding. The depth required will depend on the local soil conditions and climate. In areas with dry soil, longer ground rods may be necessary to reach consistently moist soil. Consult local codes and regulations for specific requirements regarding ground rod depth. Using copper or copper-bonded grounding clamps for all connections is essential to prevent corrosion and ensure good conductivity. Copper and copper-bonded materials are resistant to corrosion and provide a reliable electrical connection. Avoid using dissimilar metals, as they can corrode over time and compromise the grounding system. Inspecting the grounding system regularly for damage or corrosion is an important maintenance practice. Over time, grounding components can corrode or become damaged due to environmental factors. Regular inspections can identify potential problems early, allowing for timely repairs and preventing grounding system failures. Check the condition of ground rods, clamps, and conductors, and replace any damaged or corroded components. Documenting the grounding system is a valuable practice. Keep records of the grounding system design, installation, and maintenance. This documentation can be useful for future inspections, repairs, and upgrades. Include information such as the location of ground rods, the type of grounding electrodes used, and the results of grounding resistance tests. Let's delve into specific steps for installing a ground rod at the gate. Installing a ground rod at the gate is a fundamental step in grounding a chain-link fence. This process involves several key steps to ensure a reliable and effective grounding connection. Firstly, select a suitable location for the ground rod near the gate. Choose a location that is easily accessible and free from obstructions. The location should also be in an area with moist soil to ensure good conductivity. Check for underground utilities before driving the ground rod to avoid damaging any buried lines. Secondly, drive the ground rod into the earth. Use a ground rod driver or a hammer to drive the ground rod into the earth. The ground rod should be driven at least 8 ft deep, or as required by local codes. Ensure that the top of the ground rod is flush with or slightly below the ground surface to prevent tripping hazards. Thirdly, connect the gate to the ground rod. Use a suitable grounding clamp to connect the gate to the ground rod. The grounding clamp should be made of copper or copper-bonded material to ensure good conductivity and corrosion resistance. Securely attach the clamp to both the gate and the ground rod, ensuring a solid electrical connection. Fourthly, protect the ground rod and connection. Consider installing a protective cover over the ground rod and connection to prevent damage from weather or accidental contact. This cover can also help to prevent corrosion and maintain the integrity of the grounding system. Let's focus on bonding the chain link fence posts effectively. Bonding the fence posts is a critical step in ensuring that the entire fence structure is properly grounded. This process involves connecting the chain link fabric to each fence post using conductive clamps or straps. Firstly, select appropriate bonding clamps or straps. Choose conductive clamps or straps made of copper or copper-bonded material. These materials provide good conductivity and are resistant to corrosion. The clamps or straps should be sized appropriately for the fence posts and fabric. Secondly, prepare the fence posts and fabric. Clean the areas where the clamps or straps will be attached to remove any dirt, rust, or corrosion. This will ensure a good electrical connection. Use a wire brush or abrasive pad to clean the metal surfaces. Thirdly, attach the bonding clamps or straps. Securely attach the bonding clamps or straps to both the fence fabric and the fence posts. Ensure that the clamps or straps are tightly fastened to provide a solid electrical connection. Use the appropriate tools to tighten the clamps or straps securely. Fourthly, inspect the connections. After attaching the bonding clamps or straps, inspect the connections to ensure that they are secure and properly installed. Check for any loose connections or signs of corrosion. Make any necessary adjustments or repairs to ensure a reliable grounding connection. Let's explore methods for testing grounding resistance accurately. Testing the grounding resistance is essential to verify the effectiveness of the grounding system. This process involves using a ground resistance tester to measure the resistance between the ground rod and a known good ground point. Firstly, use a ground resistance tester. A ground resistance tester, also known as a ground tester or earth tester, is a specialized instrument used to measure the resistance of a grounding system. These testers typically use a 3-point or 4-point testing method to accurately measure ground resistance. Secondly, follow the tester's instructions. Carefully follow the instructions provided with the ground resistance tester. These instructions will outline the proper setup and testing procedures. Ensure that the tester is properly calibrated and in good working condition. Thirdly, perform the test. Connect the tester to the ground rod and a known good ground point. Follow the tester's instructions to initiate the test and measure the grounding resistance. Record the resistance value. Fourthly, interpret the results. Compare the measured resistance value to the required resistance of 25 ohms or less as specified by the NEC. If the resistance is too high, take corrective action to improve the grounding system, such as adding additional ground rods or improving the connections. Let's discuss connecting to a metal water pipe as an alternative. Connecting to a metal water pipe can be a practical alternative grounding method, provided that certain conditions are met. This method can provide a reliable grounding path due to the extensive underground network of water pipes. Firstly, verify the suitability of the water pipe. Ensure that the water pipe is made of metal and is in direct contact with the earth for at least 10 feet. Plastic or non-conductive pipes are not suitable for grounding purposes. Check with the local water utility to verify the suitability of the water pipe for grounding. Secondly, locate a suitable connection point. Choose a location on the water pipe that is easily accessible and free from obstructions. The connection point should be as close as possible to the fence. Avoid connecting to the water pipe near joints or fittings. Thirdly, prepare the connection point. Clean the area on the water pipe where the connection will be made to remove any dirt, rust, or corrosion. This will ensure a good electrical connection. Use a wire brush or abrasive pad to clean the metal surface. Fourthly, attach the grounding clamp. Use a suitable grounding clamp to connect the fence to the water pipe. The grounding clamp should be made of copper or copper-bonded material to ensure good conductivity and corrosion resistance. Securely attach the clamp to both the water pipe and the grounding conductor, ensuring a solid electrical connection. Let's discuss connecting to a building's grounding system as an alternative. Connecting to a building's grounding system can be a convenient and effective alternative grounding method, particularly for fences located close to a building with a robust grounding infrastructure. Firstly, verify the building's grounding system. Ensure that the building has a properly grounded electrical system that meets all applicable codes and standards. Check with a qualified electrician to verify the integrity of the building's grounding system. Secondly, locate a suitable connection point. Choose a location within the building's electrical system where a grounding connection can be made. This may be at the main grounding bus or a designated grounding point. Consult with a qualified electrician to determine the best connection point. Thirdly, run a grounding conductor. Run a grounding conductor from the fence to the building's grounding system. The grounding conductor should be sized appropriately for the application and should comply with all applicable codes and standards. Protect the grounding conductor from physical damage. Fourthly, connect to the building's grounding system. Connect the grounding conductor to the building's grounding system at the designated connection point. Use a suitable grounding clamp or connector to ensure solid electrical connection. Consult with a qualified electrician to ensure that the connection is made properly. Let's discuss the importance of using proper grounding clamps and connectors. Using proper grounding clamps and connectors is essential for ensuring a reliable and effective grounding system. These components provide the critical electrical connection between the grounding conductor and the grounding electrode. Firstly, choose the right materials. Select grounding clamps and connectors made of copper or copper-bonded material. These materials provide good conductivity and are resistant to corrosion. Avoid using dissimilar metals, as they can corrode over time and compromise the grounding system. Secondly, ensure proper sizing. Choose grounding clamps and connectors that are sized appropriately for the grounding conductor and the grounding electrode. The clamps and connectors should be able to accommodate the size and type of conductor being used. Thirdly, tighten connections securely. Ensure that all grounding clamps and connectors are tightened securely. Loose connections can cause increased resistance and reduce the effectiveness of the grounding system. Use the appropriate tools to tighten the clamps and connectors to the manufacturer's recommended torque. Fourthly, protect connections from corrosion. Protect grounding clamps and connectors from corrosion by applying a corrosion-inhibiting compound. This compound will help to prevent corrosion and maintain the integrity of the electrical connection. Let's review essential safety precautions when working with grounding systems. When working with grounding systems, it is essential to take appropriate safety precautions to prevent electrical shock and other hazards. Firstly, de-energize circuits. Before working on any electrical equipment or grounding systems, de-energize the circuits and verify that they are de-energized using a voltage tester. Follow lockout/tagout procedures to prevent accidental re-energization. Secondly, wear appropriate personal protective equipment. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated footwear when working with grounding systems. This equipment will help to protect you from electrical shock and other hazards. Thirdly, use insulated tools. Use insulated tools when working with electrical equipment and grounding systems. Insulated tools will help to prevent electrical shock if you accidentally come into contact with a live circuit. Fourthly, maintain a safe working distance. Maintain a safe working distance from energized equipment and circuits. Avoid reaching into energized areas or working in confined spaces where there is a risk of electrical shock. Following these best practices, while adhering to NEC regulations, ensures a compliant, safe, and cost-effective grounding solution for your chain link fence.